Hello guys, welcome to my YouTube channel. In this video, I will be showing you how to find eigenvalues and eigenvectors. But just before we get started, I want to encourage you to subscribe to this channel. Like the video, share the link with your friends, and also please click on the notification bell. Thank you very much for your support. All right, let's get started. All right, we have a question here that says determine the eigenvalues and eigenvectors for the equation ax equals to lambda x, where A is the square matrix. Now, to solve this problem, first we need to create the characteristics determinant of the square matrix, and we can start from here. And we have ax equals to lambda x. So we can simply subtract lambda x from both sides, and this would give us ax minus lambda x equals to 0, and we need to factor x from the left side, and this would give us a minus lambda times x equals to 0. So now note that A is a square matrix and lambda is a scalar quantity, which could be just a number, and it's not possible to subtract a number or a scalar from a matrix. So to fix this problem, all we need to do is to multiply lambda by a unit matrix, and this would give us A minus lambda times a unit matrix I, and put this in parentheses, times lambda times x equals to 0. Now the value of a unit matrix is equals to 1, so it does not really affect the value of the lambda. So we have been able to create the characteristics determinant for the square matrix. Note that the characteristics determinant A minus lambda times the unit matrix equals to 0. This is the characteristic determinant for the square matrix A. For the square matrix A. So now we already have the square matrix A to be equals to is equals to 2, 0, 1, and we have -1. We have 4, -1, -1, 2, and 0. Just put this in parentheses. Put this in parentheses. So now we are going to find the eigenvalue, and the eigenvalue is simply the value of lambda, is the value of lambda for a non-trivial solution where x is not equals to 0. For a non-trivial trivial solution for a non-trivial solution, the value of the lambda is equals to the value of is equals to the eigenvalue is equals to the eigenvalues. And for a trivial solution, x also is not equals to 0. So what we need to do at this point is to find the value of lambda, and that is actually the value of the eigen or the eigenvalues. Okay, so we bring the characteristic determinant, which is this. Just bring it here, and this will become a minus lambda times I, which is the unit matrix, and this will be equals to, now we focus on the diagonal of the square matrix A, and the first value here is 2, so we subtract lambda from 2, and then the rest of the values remains the same. And then the second, we have -1 and 4 minus lambda -1, and then also we have -1, 2 and 0 minus lambda will simply give us negative lambda. So put the whole of this in parentheses. And to find the determinant, remember we have to pick this value, and 2 minus lambda, and you can put it in parentheses and then keep the whole of this. So put the whole of this on hold and the whole of this on hold, and then we can now use this to multiply this. And this would give us 4 minus lambda in parentheses times negative lambda. Okay, minus, we also need to use this to multiply this. Okay, so -1 times -2 will give us -2, so we can simply put it here and just close the bracket. So we are done with the first part, and we can simply get rid of this from here. Next, we pick this, which is 0, and that will be -0, open a bracket. So you put the whole of this on hold, and then use this to multiply this. So -1 times negative lambda will give us positive lambda, so we just put it here, minus, we also need to use this to multiply this, and that will give us +1. So +1, and then close the bracket. So we are done with that, and we can now get rid of this. Next, pick this, and this is now +1, open the bracket. So we put the whole of this on hold and the whole of this on hold. So pick this and use it to multiply this, and that would give us -2. So negative 2 minus, and then you also need to pick this and use it to multiply. Pick this and use it to multiply this. So you can simply put that in parentheses. So this would be negative 1 times 4 minus lambda, and close the bracket. So we are done with this. Clean up the screen. And remember, the characteristic determinant is equals to 0, as you can see here. As you can see here, is equals to 0, or over here equals to 0. Therefore, we also need to, so since this is equals to this, we can also set it to 0. So take note, and automatically this would be equals to 0. I hope that makes some sense. Okay, so we are going to just write this again. So we have 2 minus lambda and open a bracket. So negative lambda times negative lambda will give us positive lambda squared, positive lambda squared, positive lambda squared, and negative lambda times 4 will give us negative 4 lambda, and also this negative times negative 2 will give us positive 2. Good. Now we have 0 over here, and 0 times the whole of this will give us 0. So we can simply skip this part of the question and move on to this part. All right, so now if we distribute positive, okay, so let's first of all do this. Negative 1, negative 1. So put this here, plus 1, which is this plus 1 here. And you have a bracket, and we have negative 2 minus. So negative 1 times 4 would give us just open a bracket, will give us negative 4, and negative 1 times negative lambda will give us positive lambda, and close the bracket, and this will be equals to 0. I hope that makes some sense. All right, let's take it one more time. Let's take it one more time. So 0 times the whole of this is 0, so we skip the whole of that part. And this positive 1, just bring it here, positive 1, and then bracket, and then negative 2, bring it here, negative 2, and then this negative sign here, you bring it here, and negative 1 times 4 will give us, just open a parenthesis, will give us negative 4, and negative 1 times negative lambda will give us positive lambda, and this will be equals to 0. I hope this is clear. All right, so next we are going to use these two to multiply lambda squared, and this will give us 2 lambda squared, and also use it to multiply negative 4 lambda, and this will give us negative 8 lambda, and also use it to multiply 2 times 2 would give us 4 after distributing 2 into the whole of this. we can now also distribute lambda. Negative lambda times lambda squared will give us negative lambda cube, and negative lambda times negative 4 lambda will give us positive 4 lambda squared, and negative lambda times positive 2 will give us negative 2 lambda. So we are done with that. So we can simply clean up this. All right. Over here, we still have plus 1. This is plus 1, and open a bracket. This is negative 2. So this negative sign, distribute it into this, will give us plus 4. This negative sign, distribute it into, will give us negative lambda. And this will be equals to 0. All right, let's combine like terms. Okay, let's work with the highest degree. We have negative lambda cube here. So let's just write it here, negative lambda cube. And after that, we have 2 lambda squared. We have positive 4 lambda squared. Together, this would give us positive 6 lambda squared. And after this, we now have negative 8 lambda and negative 2 lambda. Together will give us negative 10 lambda. And also we have positive 4 here, so we can simply bring it here, positive 4. Then now we can distribute this positive 1 into this, and that will give us negative 2. So we have negative 2, and also distribute it into this, will give us positive 4, and into this will give us negative lambda equals to 0. I hope that makes some sense. All right, so now we have positive 4 here. This is positive 4 minus 2 will give us 2, and 2 plus 4 will give us 6. So this will become, this automatically will give us positive 6. And also we have negative lambda here, which is like negative 1. So if we write this again, this will become, we have negative lambda cube plus 6 lambda squared, and now we have negative 10 lambda over here, and we also have negative 1 lambda over here. So if we combine these two, this would give us negative 11 lambda. And remember, this gave us 6, so plus 6 equals to 0. So we now have negative lambda cube plus 6 lambda squared minus 11 lambda plus 6 equals to 0. So because the coefficient of the highest degree here is negative, we can simply multiply each term by negative just to change it to positive. It makes it easier for us. So this will become, if you multiply negative lambda cube by negative 1, this will become positive lambda cube, and then plus 6 lambda squared times negative 1 will give us negative 6 lambda squared, and negative 11 lambda times negative 1 will automatically become positive 11 lambda, and plus 6 times negative 1 will give us negative 6 equals to 0 times negative 1 is 0. Okay, so now we have a polynomial of third degree here, and to factor this, we have to, if we want to factor this in twos, that would not work. If we decide to factor it in twos, it would not work. Okay, so the best way to deal with this kind of question is to have to guess a number that can be a value, guess a value of lambda that can give us the whole of this part to the 0. So if we assume that lambda will be 1, we have to test if this will be 0 if we plug 1 into the left side of the equation. So let's test it out. So this will become 1 cubed minus 6 times 1 squared plus 11 times 1 minus 6. So will this give us 0? So 1 cubed is 1, negative 6 times 1 is negative 6, plus 11 times 1 is 11, minus 6. So 1 minus 6 is negative 5. Negative 5 plus 11 is positive 6. Positive 6 minus 6 is 0. So you can see that we now have 0 on the left side, and that is equals to 0. So it means that lambda is equals to 1 and is valid. So all we have to do now, let's just clean up the whole of this. Clean up the whole of this, and we can now at this point subtract 1 from both sides, and lambda minus 1 is now a factor of this. So to get the other factor, we use the long division method, since we already have a known factor, which is lambda minus 1. Okay, just put it here. Lambda minus 1. 1 minute. So this is lambda minus 1, and then bring the whole of the polynomial inside this squared plus 11 lambda minus 6 minus 6. So first we need to divide lambda cube by lambda, and that would give us lambda squared. So just simply write the answer over here, and next is for us to use this to multiply lambda, and that will give us lambda cube, and also use it to multiply negative 1, and that will give us negative lambda squared. So now we subtract, but just before we do that, let's just clean up this from here, and then subtract. So negative 6 lambda squared minus negative lambda squared would give us negative 5 lambda squared. What I just did now is this. We have negative 6 lambda squared minus negative lambda squared. And you know, this negative will multiply this negative to become positive. So negative lambda squared plus lambda squared will simply give us negative 5 lambda squared. All right, so I hope this makes some sense. So next we have lambda cube minus lambda cube. That would give us 0. So you can just ignore that. And next we can move positive 11 lambda down. Positive 11 lambda. So plus 11 lambda. Again, we have to divide negative 5 lambda squared by lambda, and that will give us negative 5 lambda. And so if we multiply using negative 5, just use negative 5 to multiply lambda, and that would give us negative 5 lambda squared. And also use it to multiply negative 1, that will give us positive 5 lambda. All right, so let's get rid of this. So now we can subtract. So 11 lambda minus 5 lambda would give us 6 lambda. And negative 5 lambda squared minus negative 5 lambda squared. A number minus itself is 0, so this is simply 0. And next we move negative 6. Just move it down. You'll bring it down to this point. So this will become negative 6. And again, we divide 6 lambda, divide 6 lambda by lambda, and that will give us positive 6. So write it here. And after that, use the same value, positive 6 times lambda would give us 6 lambda, and positive 6 times negative 1 would give us negative 6. So I'll get rid of this. So now if we subtract, negative 6 minus negative 6 is 0. 6 lambda minus 6 lambda is also 0. So we now have, so this means that from here, from this part here, from this, we now have lambda to the third power minus 6 lambda squared plus 11 lambda minus 6 equals to 0 is now equals to, the first factor that we have is this, so bring it down. So lambda minus 1 in parentheses, and then the second factor is what we have here. Okay, so let's bring it here. Lambda squared minus 5 lambda plus 6 equals to 0. So now you can see that this is quadratic, and we also need to factor this. So all we have to do is to find two factors of positive 6 such that the sum should be negative 5. Okay, and negative 2 times negative 3 would give us positive 6, and the sum of negative 2 and negative 3 is negative 5. I come again. Negative 2 times negative 3 is positive 6, and the sum of negative 2 and negative 3 is negative 5. So all we have to do at this point is to write lambda minus 1 in parentheses, then lambda minus 2, lambda minus 3, and equate these to 0. Good. So now we can set each of the factors to 0, set this to 0. So lambda minus 1 is equals to 0. So now add 1 to both sides. Negative 1 plus 1 is 0. So this will just cancel. And we now have lambda on the left, and this is equals to 0 plus 1 is 1. And also we have lambda minus 2 is equals to 0. Just simply add 2 to both sides, and negative 2, you add the opposite of this number. We have negative 2 here, so you add 2 to both sides, and negative 2 plus 2 is 0, so this will become 0, and lambda will be equals to 0 plus 2, and that is 2. 0 plus 2 is equals to 2. And also we set this to 0. Lambda minus 3 is equals to 0. You can see that this number is negative 3, so add the opposite. The opposite of negative 3 is positive 3, so 3, 3. So negative 3 plus 3 is 0, so cancel this from here, and lambda will be equals to 0 plus 3, which is 3. So these values of lambda simply represent the eigenvalues. So lambda is equals to 1, is equals to 2, and 3. So these are the eigenvalue for this question, and I hope it makes some sense. All right, now we can proceed to the next part of this question, which is to find the eigenvector. All right, let's go on. All right, please recall that the characteristics determinant for the matrix A minus lambda is equals to 2 minus lambda, 0, 1, negative 1, 4 minus lambda, negative 1, negative 1, 2, and 0 minus lambda. We can put this in parentheses. So now, for lambda equals to 1, this would be A minus 1 times the unit vector, which will also give you 1, and this will be equals to 2 minus 1, 0, 1, negative 1, 4 minus 1, negative 1, negative 1, 2, and 0 minus 1. We can simply put this in parentheses, and this will be equals to 1 minus 2 minus 1 is 1, and this will give you 1, 1, and negative 1, 4 minus 1 is 3, and negative 1, negative 1, 2, and 0 minus 1 is negative 1. So we can put this in parentheses. And now from A minus lambda times x equals to 0, this would be 1, 0, 1, negative 1, 3, negative 1, negative 1, 2, negative 1 in parentheses times x. As you can see, this is the characteristics determinant, which is this, times x. So x is the vector, which is x, y, and z. So we can also put this in parentheses equals to 0, 0, and 0. So put this in parentheses. So now we can write this as a system of equation, and because we have, this is row 1, row 2, and row 3. So because we have 0 in row 1, it's better we start from row 1, and the coefficient of x in row 1 is 1. That simply means that we'll have x, and then the coefficient of y is 0, so we can skip that to z. The coefficient of z is 1, so plus z equals to 0. So from this, if we subtract x from both sides, then z will be equals to negative x. Now from this, the coefficient of x is negative 1. The coefficient of x from here is negative 1, and that is the value of z. So z is equals to negative 1. And at the same time, the coefficient of z is 1, and that is the value of x. So x will be equals to 1. So we have found the value of x and z. So next is to find the value of y. And we can either use row 2 or row 3. Any of them can actually be used. So let's go ahead with row 2. So row 2, we have the coefficient of x is negative 1, and that will make x to be negative. So we have negative x, and the coefficient of y is 3, so plus 3y, and the coefficient of z is negative 1, so negative z equals to 0. Good. So now let's plug in the values of z and x into this. So this will become, x is 1, so this will become negative 1 plus 3y. And z is negative 1, so minus negative 1 equals to 0. So negative would multiply this negative, and that will become positive. So this will become negative 1 plus 3y plus 1 equals to 0. Now, if we combine negative 1 and positive 1, automatically this will give us 0. So we now have 3y is equals to 0. So now divide both sides by 3. Divide both sides by 3. And 3 would cancel 3 from here. And 0 divided by 3 is 0. Therefore, y is equals to 0. So we now have x is equals to 1, y equals to 0, and z is equals to negative 1. Therefore, for lambda equals to 1, x is now equals to 1, 0, and negative 1. So this is the eigenvalue vector that corresponds to lambda equals to 1. Okay, so I hope that makes some sense. All right, let's also calculate for lambda equals to 2. Then we have a minus 2 equals to 2 minus 2, 0, 1, and negative 1, 4 minus 2, negative 1, then negative 1, 2, and then minus 2. So we can put this in parentheses, and then 2 minus 2 is 0, so this will be equals to 0, 0, 1, negative 1, 2, negative 1, and then negative 1, 2, negative 2. So from a minus lambda times x equals to 0, then this would be 0, 0, 1, negative 1, 2, negative 1, negative 1, 2, negative 2, multiplied by x, y, z equals to 0, 0, and 0. So now row 1 is this, row 2 is this, and row 3 is this. So now that we have 0, 0, 0 over here, the coefficient of x is 0 here, the coefficient of y is 0, and z is 1. That simply means that for row 1, we only have z equals to 0. And to find x and y, we can either use row 2 or row 3. So now we can pick row 2, and the coefficient of x is negative 1. That means we have negative x plus 2y minus z equals to 0. So now, since z is equals to 0, then we have negative x plus 2y equals to 0. So if we add x to both sides, then 2y will be equals to x. So what this means is that, you see, we have 2 as the coefficient of y, and that is the value of x. So x will be equals to 2. And we have 1 as the coefficient of x, and that is the value of y. So y is equals to 1. So we have found that z is equals to 0 over here. So what this means is that x is equals to 2, y is equals to 1, and z is equals to 0. So for lambda equals to 2, y will be equals to 2, 1, and 0. So this is the eigenvector that corresponds to lambda equals to 2. Now, let's move on to the next one. For lambda equals to 3, this would be a minus 3 equals to 2 minus 3, 0, 1, negative 1, 4 minus 3, negative 1, negative 1, 2, and negative 3. Put this in parentheses. So this would be 2 minus 3 is negative 1. So this would be negative 1, 0, and 1. Negative 1, 4 minus 3 is 1, negative 1. Then negative 1, 2, and negative 3. Put this in parentheses. Now from a minus lambda I times x equals to 0. We can pick the first row. Okay, so never mind. So first we write down the value of negative 1, 0, and 1, and then negative 1, 1, and negative 1, and then negative 1, 2, and negative 3. And so we multiply this by x, which is now x, y, z. And this will be equals 0, 0, 0, 0. So this is row 1, this is row 2, and this is row 3. So row 1, we already have 0 in row 1, so we can simply use row 1. And the coefficient of x is negative 1. That gives us negative x. And since the coefficient of y is 0, we can skip that and move to the next one, which is z. The coefficient of z is 1, so this means plus z equals to 0. And if we add x to both sides, then z will be equals to x. So what this means is that the coefficient of z here is 1, and that is the value of x. X is equals to 1. And the coefficient of x here is 1, and that is the value of z. So z is equals to 1. I hope that makes some sense. So from row 2 and row 3, we can choose any of them, row 1, row 2, or row 3. And we can still work with row 2. We can still work with row 2. So row 2, we have the coefficient of x to be negative 1. So that will be negative x, because we need to find the value of y. Okay, so we are trying to make use of row 2, but either row 2 or row 3, both of them will give you the same answer. So we are working with row 2. So row 2, we have negative x plus y, negative z equals to 0. And you can see that x is 1 and z is 1. So this will become negative 1 plus y and negative 1 equals to z equals to 0. And negative 1 plus negative 1 is, we have negative 1 here, plus negative 1 will give us negative 2. So this will become y minus 2 is equal to 0. So if we add 2 to both sides, negative 2 plus 2 will be 0. and y will be equals to 0 plus 2, which is 2. So as you can see, we found the value of y to be 2. So x is equals to 1, x is equals to 1, y is equals to 2, and z is equals to 1. So for lambda equals to 1, the eigenvector for z will be equals to 1, 2, 1. So the eigenvector for z equals to 1, 2, 1 corresponds to a lambda equals to 3 and not 1. Please take note of this. Lambda equals to 3. Okay, so this is the answer to this question, and if we need to bring all this closer, we have in the first place x so the first one we got x, okay, x is you can see the value of x here. Okay, x is equals to 1, 0, negative 1. So let's put it down. 1, 0, negative 1. 1, 0, negative 1. So x is equals to 1, 0, negative 1. And y, the value we got for y is 2, 1, 0. 2, 1, 0. 2. So y is equals to 2, 1, 0. So if we want to write this accordingly, then x is equals to 1, 0, negative 1. Y is equals to 2, 1, 0. And z is equals to 1, 2, 1. So this corresponds to lambda equals to 1. This corresponds to lambda equals to 2. And this corresponds to lambda equals to 3. So can clean up this, get rid of this from here. So these are the eigenvectors for this question, and I hope it makes some sense. Alright, so if you find this video useful, please don't forget to subscribe to this channel, like the video, share the link with your friends, and also please click on the notification bell. Thank you very much for your support. I'm looking forward to seeing you in our next video. Bye bye.